They're called max-min problems because you're going to either try to find a maximum or a minimum. And this is super important in a lot of real life things, because if you were like doing some work where you could make different amount of monies depending on what you did, you'd probably want to make the maximum amount of money. And then also you sort of look at, well, how long is it going to take me to do this? I could do it in different ways. Often there we want to say, well, I want to find a minimum amount of time. So we're always looking to we like to minimize how much work we do and maximize how much money we make. And most businesses are like that as well, right? If you're going to, if you take out your GPS and you need to go somewhere, it's like, ooh, I want to take the longest route? No. You want to take you either take the one that takes the least amount of time because you want to go the fastest, or sometimes you say, I want to drive the least amount of kilometers so I don't use as much gas. There's different things that come into effect. But max-min problems are all over in our real life, and they come up a lot with parabolas. So, this is an easiest question because in the word problem, they give you the equation. So, find the maximum height of a ball thrown from one friend to another if its path follows this equation. So do you see that the equation is a parabola? And height is a function of time. So at different times you have different heights. Makes sense, you throw a ball, it would go up in the air, reach a maximum, and then come back down again. So we want to find out where that maximum height is. And we imagine, like this is the situation, you can draw your axes, the person is probably throwing it, and what are the units here? Height of the ball in meters. Okay, I like this question a little bit because it's a little bit unrealistic. They must be on top of a building or something, because at time 0, can you see that the y-intercept is 9 meters? Can you see that this is a parabola that opens down? So this is probably what's happening to the ball. So we already know that because we've analyzed equations before. What we're trying to find is the vertex, because does the vertex make sense that that will be the highest it ever gets? And this would be the time t when it happens. But the question is not asking for the x-coordinate, it's asking for the y-coordinate because it's asking for the height. So if I can find the vertex, I can solve all my maximum min problems. And this is the easiest max-min word problem because they give you the equation. The harder ones that we'll get to, we have to make the equation, and then we have to find the vertex. So we solve by completing the square. H equals, we factor out the -2. We factor out the -2 out of this, and negative out of a positive 4 would be -2t. Leave a space. Still have the +9 here. Leave a space. And now if we complete the square, that -2 tells us it has to be t minus 1. And if it was a -1, there would be a +1 there. But what have we actually done? That +1 would get hit by a -2. So since we've actually subtracted 2, we have to compensate and add 2 to equal it out. +11. So then our vertex is 111. This is not necessary in the brackets, but it's just good because sometimes they'll ask this kind of question. Is time in seconds? Yes. So just ask for the max height. So that's your y-coordinate. And the max height is 11 meters. We need to make sure that we include our units. Sometimes they're going to ask, when does that happen? And in this case, it happens 1 second after it was thrown. Easiest questions, because really, if the equation's given to you, then the word problem isn't really a word problem. It's just like saying, can you find the vertex? So, what happens with ones that are a little bit more complicated? Find two numbers whose sum is 12 and whose product is a maximum. So now no equations are made, and we have to come up with variables for the two numbers. We want a maximum product. So we are going to set up an equation that says product equals, because we're always finding a maximum y value. So our y value will be product, so I'm going to use p in this example. And product means multiplying two numbers together. So sometimes in these word problems, we can write things out in words to start off with. Like we can write our mathematical equation, like I have my first number and my second number, okay? That doesn't help me solve anything, but it gives me the idea, right? A product is two numbers multiplied together. Now we have to come up with a variable, and we have to come up with an equation. So we decide, what's our first number going to be? Let's just say it's equal to, I can even use an equal sign there, is equal to x. And some people say my second number is y, but then there's a problem because you have too many variables. If my first number is x, we'll always be able to write our second number in terms of x. In other words, if I picked a number here like 5, if one number is 5, what's the other number? 7, right? Because they add up to 12. If one number is 3, what's the other number? 9, because they add up to 12. If one number is x, what's the other number then? So you could do it with numbers. Can you do it with algebra? Right? If one number is 5, the other number is 7. If one number is 8, the other number is 4. If one number is x, the other number would be y. Well, it needs to only be with x's.
X minus x. Wait.
How are we going to do that?
It would be
They add up to 12.
12 minus x.
12 minus x. Right? Whatever, you take it away from, and then you would have what's left. Does that make sense?
Yeah.
And now, look what we get. We get product equals, my first number was x, my second number was 12 minus x. Can you see that this is a parabola in factored form? But that doesn't help us with our vertex. I would have to multiply it out. I'm going to just erase this, because we're doing this. We need to create the equation. Yep, we're doing it. If I multiply this out, the x times the minus x, that'll be minus x squared. The 12 times the x. You okay that I wrote it in the opposite order to put the x squared first? It's a parabola. It's a parabola that opens down. Does that make sense? Its vertex is going to be a maximum. We want to find the maximum product. Now all we need is the vertex. So we have to complete the square. We always factor out, in this case it's going to be a negative. I'm going to push plus 0 here because there is no number. But just to write, I always write something there. You don't have to write plus 0, you could just leave it blank. But if I factor the negative out, this will be x squared, and negative out of this, that'll be minus 12x. I leave my space, and I leave a space. Oops, product equals. And now we can complete the square with a minus 12x. What is that? That's a hint. What has to be inside the completing the square? Minus, so it's going to be minus. What number? 6, right? It's always half. Now, if there's a minus 6 there, there would have to be a plus 36 there. What have we actually done though? There's a minus out front. We have actually, by putting that number in that space, we've actually subtracted 36 on the right-hand side. So to compensate, we would have to add 36. And then our vertex is 6, 36. What did the question ask us to find? Find two numbers Well, how do we find the two numbers? What was x? This is where we have to go back. What did we make x? We made x, that was our first number. So our first number is 6. How do we find our second number? We wrote it up here. Our second number is going to be 12 minus the x. So our second number is also 6. To make, and they didn't ask for this part, but let's write it out. Because this part is always going to be the max or min. In this case, it's the max.
Hi, could I please have Chloe to the office for a moment?
All right, she'll be right down.
Awesome, thank you.
Now, quick check. 6 times 6 is 36. If you had picked 5 and 7, what's the product? 35. If you had picked 4 and 8, 32, right? If you picked 3 and 7, no, that doesn't even, yeah, 3 and 9, 27. So we could do a little mental math to double check this. The thing that's hard though is that we only checked whole numbers. It could have been an answer where 1 was a decimal. But if we do this method, we will know for sure that this makes the maximum because we found the vertex of the parabola that represented the equation. So this is a number question. Number questions, we'll say find two numbers. They'll give you some sort of relationship. Maybe the difference between the two numbers is 4. So if one number is 2, the other number is 6. If one number is 8, the other number is 12. If one number is x, the other number would be x plus 4. So you have to be able to, sometimes if you can do it with regular numbers, then you have to translate it to algebra so that you can set it up. So your first number's in terms of x and your second number's in terms of x. And then they're going to ask you for different maximums and mins. Not always going to be a product. Maybe they'll say, like I've seen one where it's like a minimum sum of squares. Like it means you square the first number and you square the second number and you add them up. So you have to read these questions and the setup, max min problems, this is where we're going to have to develop our skills because that's going to be the hardest step. Once you set up the equation, what was the hardest thing yesterday was completing the square to find the vertex. Now the hardest thing from yesterday becomes the easy part of this question. Okay. There we go. Oh, I love these ones. Area problems. Because this seems like a really practical thing that someone would actually need to do. I don't know if you're going to buy chickens in the city, but if you have a farmer and you only have so much fence that you have to use, right? And you need to keep your chickens inside that fence, otherwise they're going to run away. But you want them to have as much space as possible, right? You can make a very dumb fence where you go out like 2, maybe 5 centimeters and run 90 meters that way. And these chickens would have to, they could only, like, they'd be squished in this long, narrow corner that probably wouldn't be healthy. Right? Your chicken soup would taste terrible because all your chickens would be like, not very healthy. So how do we build the most and biggest area possible while you're restricted? You only have 80 meters of fencing. Often in these area questions, it's nice to draw a picture. So, man has 80 meters of fencing to build a coop for his chickens. He has a barn, so I'm going to look top view, are you okay? Top view, this is my barn. I'm looking straight down, and he is going to build, oh, and often they'll say in this question, I don't know if it's here, what dimensions for, and they'll usually tell you what shape it's in. I don't see it in this question, but we're going to make this as our idea. My lines are not, we'll pretend our barn isn't bent. Can you imagine those are all straight lines? Like I'm struggling with drawing this morning. Actually, I hate bugs. I gotta redraw it. I'm gonna redraw my barn straighter. Here we go. There's my barn, nice and straight. Okay. And we want to find, what are we wanting to find a maximum of? Largest area, maximum area. So we need to make an area formula. And you know your area formula is, and I'll write it out in words, length times width. You know that, but the problem is length isn't a number you put, like, we have to put in stuff. So, let's do some possibilities. Let's pick a random number for this side. He has 80 meters of fencing. How much could the farmer put on this side? What's an example? Can't put 700, right? He's only got 80 meters. Put 20. Good. He puts 20. What would this side be? 20. And what would this side be? 40. Perfect. Let's pick another number. 30. If he's 30 here, this side would be 30, and this side would be 20, because it has to add up to 8, right? And those give different areas. One had an area of 800, one had an area of 600. So definitely the one is better, more space for his chickens. Okay, so now, what did we pick first? We picked this side. So let's make this side X. Then I asked you, what's this side? Also X. Then I asked you, what's this side?
80 minus 2x.
80? Because there's 80 in total, and you used up 2 x's already. So whatever's left will be on that side. And now, we can write our area, because the length is 80 minus 2x, and the width, doesn't matter which you choose as your length and which you choose as your width, is going to be x. If you multiply that out, do you see that makes a parabola? The negative 2x times the x will be negative 2x squared, and the 80 times the x will be plus 80x. Which way does this parabola open? It opens down. Does that make sense that its vertex is a maximum? Now this farmer could just keep guessing and checking. He could be designing on paper. And this is what happens in real life. A lot of people do that. They just design on paper and they say, I'm happy enough. But if you know the mathematics, it's not that hard to solve, and then you know you have the biggest possible. So, let's complete the square. I would factor out a negative 2. I guess there's a plus 0 here. You don't have to write that, but if I take out the negative 2, I'd have x squared. A negative out of a positive will be negative 40x space and space. Complete the square. If it's a minus 40x, what has to be in here? Minus 20. You getting good at that part? And then, if that's a minus 20, what goes in our first blue space? Plus 400. But what have we actually done? We've done minus 800, so to compensate, we add 800. And now the most complicated part of this question, you have to add the 0 and the 800 together. Whew. You probably need a break. It's okay. I understand. A little mental break after that one. And our vertex. Hey, you guys actually, your first guess was the best one. Right? Because this is our x, and this is our max or our min. In this case, it's a max. So if we look at our diagram, and we look at what is the question asking us? What dimensions? So these are word problems, so do we end word problems with a little sentence? The dimensions are x is 20, include our units, polymeters, by, what would the other side be then? 40. And it didn't ask for this part, sometimes it does. If it asks for the maximum area, you have to make sure your units are correct, of 80 meters squared. This is really, really practical, because can you see a person having only a certain amount of materials? They have only a certain amount that they can build. They want to build it in a rectangle. Now they can figure out the maximum area so their chickens are happy as possible. And then maybe they can get more chickens. Okay. So, we drew the picture, created the equation, and where are we in our notes here? There was a profit one. I'm going to find that one. Oh, this is the same question. Okay. There's the profit question. This is good for businesses, maybe not good for consumers, because they're trying to figure out how much money they can make. So if the school wanted to make the most money off of students, it's not very nice of the school, but they could decide to do this, right? They could sell sweatshirts that they got for free for $20. And they know that 300 students would like them. And they're like, wouldn't that be nice that they could sell 300 of these to students even though they got them for free? But no, they get greedy. And they find out that if they increase the price to 25, yeah, some people might not buy them, but maybe they'll still make more money. So thinking of the greedy school, the school wants to make the biggest profit possible. Okay? So first of all, when we look through the question, we look at what they want as a maximum or minimum. In this case, the question wants to find a maximum profit. So we know that we're going to write our equation as profit equals, well, how do you calculate your profit? It's what times what? How would they figure out how much money they have?
How much you sell for.
The price, okay.
Buy it.
And then number sold. Is that, it's really good to write this out in words so you understand what you're thinking about. Because if you jump right into the algebra, sometimes it's like your brain will just get lost in X's and stuff. So, writing down words, you have an idea. What is the price? Well, it changes. It starts at 20, but you could add $5. You could add $5 once, you could add $5 twice, you could add $5 3 times. So what we do here is we choose X, we're going to choose X to be the number of times we add $5. So what is the price? Well, the price started at $20. And if you added $5 once, it would be $25, right? If X is 2, you added $5 twice, the price would be $30. Does that make sense for a price that could change? You could take $5 off. If X is -1, then you'd sell them for 15, right? You could take $5 off 4 times and sell them for $0. I'm gonna guess your profit's not gonna be a maximum. But lots of students will be like, I'll take one, right? More people would probably choose that then. Now, how many are you going to sell? Well, if X is 0, and you're at $20, the number sold is 300, right? But what's going to happen if you add X once? The number of people
It's subtracted by 30.
subtract by 30. So every time you add an X, you have to subtract by 30. Does that equation make sense? These are the most profit ones. They're the most complicated because setting up the equation is the hardest. But what you do is you say, let X equal the number of times you make an adjustment. You will always have, like here's our starting thing, when X is 0, right? When X is 0, you just have 20 times 30, you'd make $6,000. Student got these sweaters for free, they're making $6,000. They should just, school should be nice and just give them to the students for free. Yeah, but no. They're a business-minded school. They want to make as much money as possible. So they're like, well, we can make money off of this. And then they do this math and they say, okay, well, if I multiply this out, you see that this is going to make an x squared equation. If I FOIL it out, and I'll just do it in the right order, 20 times 30, that'll be 6,000. 20 times minus 600x. This will be plus 1,500x, and 5 times minus 30 minus 150x squared. We've got some bigger numbers, eh?
Yeah.
Is it a parabola?
Yeah.
It's got the x squared. Does it open up or open down? It opens down because the x squared is minus. So you're going to have a maximum, which is what we want. I'm going to rewrite it with the x squared first. I'm going to combine those like terms. And the numbers are big, but we have to complete the square anyways. So I take out the minus 150. That's super easy. That'll be x squared. I'm going to keep the 6,000 out here. Okay, how many 150s are there in 900? Count them. 150. 6 of them, right? And it's a minus, so this will be a minus 6. Leave a space. Leave a space. Complete the square. If it's a minus 6, what goes in here? Minus 3. And if it was a minus 3, what would go into the first space? Plus 9. What have we actually done? 159 times. Negative, because it's negative. 1350. Excellent. So then to compensate, add 1350, which makes this plus 73. And our vertex is 3,7,350. What did the question ask? What price? Is this the price? No, this is X. This is the maximum. This is the maximum. But that's X. So we have to think, what did X stand for?
How much you're adding to the cost.
How much you're adding to the cost. The price, if I circle the price here in yellow, this is the price in yellow. If X is 3, the price would be $35. Word statement in the end. So this is also what makes this one probably the hardest one. A price of $35. of $7,350. Businesses do this all the time, right? Are Jets playoff tickets cheaper or more expensive than regular season? More expensive. Why? It's a big event. People are willing to spend more money, so they're like, oh, if people are willing to spend more money, what should we do? Make more money. Raise the price, right? Right? They want to raise the price almost to like, we still want to sell it out. We don't want to piss off too many people, right? Because if the Jets tickets were like $5,000 each, what's going to happen in the first playoff game? There's still going to be some stupid, there's still going to be some people that can afford that. Maybe they're not stupid, they're just ultra rich, and we just get a little frustrated with that, right? But they can still afford that. But they won't make enough money because there's not enough people that can afford it. Well, so they push it to a price where they're like, I can still suck that money out of Lucas. He'll still want to go to that game. And he'll say it was worth it if they win. And he'll be mad if they lose. But businesses are doing this all the time. They're trying to figure out what's the maximum price. These are super simple situations because there's a lot of different variables that come into play, right? How much is a hot dog at a Jets game? $10. $10, right? You should almost fill your whole jacket full of hot dogs and sell them in the aisle. You can make so much. You would can you imagine your smell? Came to the Jets game. Your whole jacket is just filled with hot dogs. You're only selling them for $4. They cost you 82 cents. You're making lots of money. But you're going to smell like hot dogs for a long time if you don't wash that jacket. Okay? So we're always trying to figure out these things. Maximums. What's a maximum profit? So these are the four main types of questions. And I have another handout which practices them some more. Okay. And these ones, you can try on your own. Some of them are very similar, but I add a little bit to them so that they take some thinking. So if you want to move around and work in small groups, another 6 on there.